Going to solve this problem. A pi network has been shown in the below figure where 0.5 I3 is a current controlled current source. Obtain the Z parameters for the pi network shown below. Okay, so how to do it is, let us try to verify. Okay, so here you can see this is an problems on dependent source, very important. Let's try to write down the basic equations. The basic equations are v1 v2 is equal to, so we have the basic fundamental equations are z11 z12 z21 as well as z22 multiplied with i1 and i2. Therefore the basic equations are V1 is equal to Z11 I1 plus Z12 I2 is one equation. Second equation, V2 is equal to Z21 I1 plus Z22 I2. So here, in order to solve this problem, initially I am considering case 1, output port is open circuited, that is I2 equal to 0. Here I2 is 0 here, and again here I2 is 0. So whenever I2 is 0, the parameters what we are going to get is Z11 is equal to V1 by I1. The next parameter is Z21 is equal to V2 by I1. So these are the two what we need to find out. So here let's try to apply on this network. When you're trying to apply this network, here I2 is 0. Okay, so the voltage at this point is V1, the voltage at this point 0, automatically it will shift it to this point. Okay. Now the voltage is shifted, so therefore I'm going to have a current control current source. Okay, so if you shift or don't shift, let's try to resolve in more simplified manner. So we are going to have V1 driving a current of I1, and here we have a current dependent current source with a magnitude of 0.5 I3. We require the relationship between V1 and I1. Okay, so how to write down this current? Let us try to understand. So here we are going to have this is 8 ohm and this is 5 ohm, and these are connected to same point. Here we are going to have V2. So now we require the relationship of this one. So already in this branch, what is the given in the problem is, what is the current flowing is I3. So the current flowing in this complete branch is I3. Okay, now how we are going to take the approach is, let's try to apply the Kirchhoff's current law at this node. So what are the entering currents? Entering current is, what are the entering currents to this node? I1 is entering. Leaving currents are 0.5 I3, and the current which is flowing in this branch is I3. So whenever you make it open circuited, the same current which flows in 8 ohm and also will flow in 5 ohm. So this is nothing but plus I3. Therefore, I1 is equal to I3 I am taking common, which is nothing but 1.5 times I3. But when you see here, here in this I3, so this is I3. But I want to express I3, what are the things I require? So I want to express I3 in terms of V1. Why? Because already here V1 I1 is there, we require I3 in terms of V1. So check it in the problem where we can express I3 in terms of V1. Okay, so here I can write down the I3 like this. Okay, so I3 is flowing in this branch, so the voltage at this node is V1. Okay, how to write down the current I3? So the current I3 can be written as, so this is the current I3 which is flowing in this branch. So V1 minus 0 divided by 8 plus 5. So which is V1 by 13. Okay. So therefore I3 is equal to V1 by 13. We got it here. So try to substitute in this equation. So I1 is equal to 1.5 times V1 by 13. We require the ratio of V1 by I1. So therefore this will come to the denominator. V1 by I1 is 1.5 divided by 3. Now this is 13 divided by 1.5. So here you are going to get the value of Z11 as 8.66 ohms. Successfully we find one parameter. And next parameter, what we need to find out is, so the next is also the same because output port is common. So here we need to find out I1. I1 is equal to 1.5 times I3. In this equation, I1 is already there. The problem is with I3. So we want to express this I3 in terms of only V2. In terms of V2. Identify where we can express I3 in terms of V2 here. So from this equation, this is V1 and this is V2. So now I want to link this V2 and I3. Okay. So now what to do is, so the current I3 is flowing only in this branch. So I3 I can write down it as I3 is equal to V2 minus 0 by 5. So therefore, uh, from this substitute in this equation, I1 is equal to 1.5 times V2 by 5. What ratio we require is V2 by, so we require V2 by I1 is equal to 5 divided by 1.5. Okay, so this is 3.33 ohms, which is nothing but Z21. It's very, very important. So solving these kind of problems require more attention and more talent. That's why I continuously make you to do this kind of problems, which will help you in solving gate problems. Okay, so now we find out one port. Now let us try to find out the next one. So the equations we have here to substitute them is again is, so these are the equations what we are having. So previously we had made output as open. Now we are going to make input port as open circuited, which is I1 is equal to 0. Substitute I1 is 0 here, I1 is 0 here. Therefore we are going to get Z12 is equal to V1 by I2. One need to find out one. Next one we need to find out Z22 is equal to V2 by I2. You need to solve this. So when you see this network, input is open circuited. When input is open circuited, the network can be solved. This V1 will be transformed to this node. So we are going to have a current dependent current source of magnitude 0.3 V1. The voltage at this point is V1. So and it has 8 ohms, and the current in this branch is I3 of 5 ohm, and here we are going to have V2, this is plus V2, and this is current I2. So now we want to link each other. So the current which is completely flowing in this branch as per this is 0.5 I3 is the current flowing in this branch, and the current in this branch is I3. So now from here what we can do here is, so we are going to apply the nodal analysis. Apply Kirchhoff's current law at node shown below. So here what are the entering currents? I2 is one entering current. I2 is the entering current. Leaving current is I3 plus 0.5 I3. So here I can write down I2 is equal to, I'm taking I3 as a common, 1 plus 0.5 which is 1.5. From here we require the relations of V2 and I2. So already I2 is there, we need to express I3 in terms of V2, identify this relation. Okay, so from here I need to write down I3. So how to write down I3? So here V2 is there, this is short circuited automatically. This node will be shifted to this node, and this node will act as an V2 node. Why? Because all are connected to the same line. So now we require this relation. Therefore, I3, the current flowing in this branch with respect to V2, I3 is equal to V2 minus 0 by 5. Therefore, I can write down I2 is equal to V2 by 5 into 1.5. So now I require the relationship of V2 by I2, which is 1.5 by 5, which is 5 by 1.5. So 5 by 1.5, which will give you an value of 3.3 ohms, which is V2 by I2. This is the value of Z22. But we require one more, which is very interesting, V1 by I2. So in order to obtain this equation, we want to write down, so what is the current which is flowing in this branch. I'm going to take this current separately. So I'm writing this current as 0.5 I3 current is equal to, I want to link all V1 I2. Okay, so here uh, V1 is there and I2 is linked with this equation here. So 0.5 I3 I can write down it as, what is the voltage at this point? V2 plus V2, no? So current is leaving. What is the leaving polarity of the voltage? V2 minus V1. Okay, V2 minus V1 divided by 8. So V2 minus V1, we can write down it as 4 into I3. This is one equation we got. We require is V2 by I2. So here what we are going to do here is, we need to see that the relationship between, how we can write down V2. So here V2 I can write down, I need to solve this, either one should be solved. So V1 I actually require, so V1 is there, V1 I require, and I require I2. So I'm writing this as I2, and I'm going to express this V2 in terms of I2. Okay, so V2 in terms of I2, but here the disturbance which is creating to me is I3. So I'm going to do some modification here. So how to write down I3 here? So I3 is equal to V2 minus 0 by 5. So from here we can write down, we can convert this, substitute this in above equation. So V2 we can write down it as 5 I3, and this will come to this side, minus 4 I3 is equal to V1. So this is I3 is indirectly V1. So go and substitute here. So we are going to write down the V2 equation here. So when you are going to substitute here, so we are having the value of I1, we can, what is the value of I1? We can write it as I3. And what is the value of I2? So the value of I2 we had already written here. This is I3. So this is nothing but I3 into 1.5 times. So there is no, we have got this value. Okay. So I2 is V1, sorry, uh, this is V1, and now this is also I2 also we are going to express in this equation in terms of I3. So there is nothing but 1 divided by 1.5. So we are going to get this Z12 as 0.66. Okay, so this is the value. So if I write down all the things in group, Z11, Z12, Z21, Z22. So what is the value of Z12, which is 0.66. The value of Z22 is 3.3 ohms. When you go up, Z11 is 8.66. Z21 is 3.33. So this is the resultant Z parameter equation model. So we successfully find all the Z parameters. The logic here is, so already we have a relationship here to find this equation. Already we have a relation here, I2 is equal to I3 into 1.5. Now we want to express this V1 also in terms of I3, then only we can find a solution. Okay, so if you find the solution only, the things will be more better. So why I write down this equation is to transform or to find out I1 in terms of I3. Therefore, so here you can see here there is no equation which consists of only V1 and I2. Okay, so that's why I transformed into the required format. So these kind of problems are very important in competitive exams. If you feel the video is useful, if you want, you can revise the session once again. So output side we are making open and we are finding the parameters as V1 by I1. In order to find it, we applied a KCL and we express the current. See that there should not be any current I3 or something else. Everything should be in terms of V1 and I1, a transform. So same equation I taken and there should not be I3. I expressed I3 in terms of V2. So there is expressed as like this. So here the case is different. Again the same I applying here and there should not be I3. I expressed I3 in terms of V2. I got this value. But the confusing point here is, so there is one more current. So I taken this current in this branch is 0.5 I3 like this, and I expressed this V1 also in terms of I3. Already I2 is I3. So automatically these are the parameters. So this kind of problems, by looking the video you don't get anything. Just you have to solve and write down the given question and try to solve of your own and cross check with the answers. The methods what I am doing are my own talent. I learned, I practiced, I become more professional. That's why I'm able to do it. So if you're feeling the videos is very useful, please like the video, please share with your friends, and if you have any doubts, let me know in the comment section. And if you're watching the first time the channel, please subscribe the channel. This is a free channel for the development of students and faculty. Yours obediently Ram. We'll meet in the next video. Thank you for watching.